Okay, so we created a looper and a basic sampler in the last video. Now we're going to change this and make it a slightly more interesting sampler by incorporating the ability to reverse the samples. And I'm going to show you a different way to do the sample stuff instead of trans ratio. So I'm going to take all of this except for the K slider. I'm going to delete that. I don't want to record anymore, so I'm going to delete that. And we're going to change the name of the buffer to samply, because guess what? This is going to be for a sampler. So we need to do that for waveform, for the set, and for groove. And this time I'm going to give it a much longer value. Let's do 1600. So this will be a little bit over a second and a half. Now here on the desktop, I've got a file called catscream.wave. With buffer, I can read a file as long as it's in the same directory. So what I'm going to do is save this onto my desktop. Call it sampler2. Then I'm going to create a message, read cat scream.wave. And it's just a cat meowing. I just called it cat scream because I think I had another cat meow one. There we go. There is the cat. So now at this point, if I set that to 1, we have a cat meowing. Pretty cool. I need to change a couple values to correspond to what's in buffer. So the start point is still 0. The end point now, though, will be 1600. And that should be pretty cool. I can leave all of this load mess and the line over here. That will work. But what we're going to do is we're going to make a couple changes. I'm going to get rid of these values here. I'm going to leave load mess to auto start the loop, but I want to make this a little bit more interesting. So first things first, I'm going to change the K slider by going into the inspector, and then all the way here at the bottom it says what's the low MIDI key offset. I'm going to set that to 0. So that's going to be the lowest possible note. Then what I'm going to do is connect that up to do a couple of different things in a couple of different ways. And this will be really interesting. So I'm going to use a trigger integer 0 bang. So as soon as it receives this integer from the pitch outlet of K slider, it's going to fire off a bang, fire off a 0, fire off that integer, and that's what we're going to get. I'm going to send this bang to start loop. That's important. I'm going to send the 0 to sig. That's also important. Then I'm going to do a little bit of math. I'm going to create an expression, and that is going to be pow 2 point comma $f1 divided by 12. And I know I did it correctly because it didn't just go red and an error did not pop up in the console window. So this is going to give me a really, really functionally useful thing. What I've created is I've taken the idea of raising this to 2 to the power of x divided by 12. And that is going to create a signal in semitones. So as I go up, it gets more and more semitones. As I go down, it goes less and less semitones. You can take a look at it with this float here. So at 0, it's 1, 1.2, and then if I jump all the way up here, it's going to be 2, 4, and 8. So this is effectively saying C at the lowest position, MIDI note 0, is my root key. I'm only going up. Why are we going to do that? Well, I will show you in a little bit, but specifically it's because we're going to do some stuff with playing around with this expression later. But this is the basic algorithm for transposing a sample, is that you're multiplying this by the root frequency, and that will give you the change in frequency you need. Now, before I connect this up to SIG, I want to also be able to play this in reverse. So what I'm going to do is I am going to create an object, and this is a really cool one called G switch 2. And this object takes two inlets. It takes a inlet that toggles between the two states. So I'm going to use a toggle for that. And then it takes the data that is going into it. So this is going to effectively say, okay, what are we going to do with this data? Are we going to send it to the left or to the right? If I close the patch and lock it, 0 is off, so it goes to the left. 1 is on, so it goes to the right. So off, on, left, right, left, right. Pretty cool. I'm going to take the left outlet of that, and I'm just going to connect that directly to SIG. Nothing else. With the right, however, I'm going to have a little fun. I'm going to multiply that by -1 point. So a -1 floating point, and send that to SIG. You probably already guessed, this now lets me play my samples in reverse. And in fact, that is exactly what it's going to do. Now, for some reason I am not 100% sure of, it only works if I have a loop on. I suppose I would have to reverse the minimum and maximum going into groove, but I prefer to leave loop on with this because then I can play around with this and get better sounding samples. But yeah, here's reversed. Of course, cat screaming doesn't really sound like it's reversed. So you know what? Let's do, copy that. And we're going to read something within the max path. How about good old Anton dot AIF? So why is it important that we have this expression and we're not just using trans ratio? Well, let's move these out first of all so that we can see it. The reason is that using this expression allows us to play around with different transpositions. Like say we want quarter tones. Let's change it to 2 to the power of x over 24. So now, you can see that I have to go 2 full octaves to transpose by 2 to double the octave. So this is rearranging everything so that instead of having semitones, I have quarter tones. I could do something different, like maybe 17, which will give me different step sizes. How about 5? Let's try that. Or let's try something really, really just kind of out there. How about 31? And I can also play around with the number that we're raising by the exponent. The Bolin-Pierce scale is famously derived from 3 to the power of x over 13. This is going to overshoot the octave, and it's going to give us what's called the tritive, which is approximately-ish a just intoned 12th. So a lot of interesting stuff you can do with this equation just to play around with the tuning. If you want to get into that some more, I highly, highly, highly recommend that you take a look at some of the books that I've put in the resources on the course guide and have fun with it. This is a really cool one.